Hello there guys and welcome back to another epic Inexorable maths video. We're looking at some A-level maths today. So in this video we're taking a look at an introduction to mathematical proofs. So basically it's like, how do you even start? How do you even start with proof? How do you prove something? What's the idea of a proof? What's the point of it? We're just going to quickly answer that question and then we'll do a quick example at the end. So here's an intro to mathematical proofs. So I've written some things down. This is just important things to know. So proof is basically, it's just a logical and structured argument to show that an unproven statement, which we call a conjecture, is true. So, you know, if I said something, you would say, well, how do I know that's true? Can you prove it? That's the idea. And we want to, as this next paragraph, you typically need to use previously established theorems, which are basically just mathematical facts to prove things. So, you need to bring up other things that are also true in maths, and we can talk about lots of those in the future in order to prove. So what you can't do is if I gave you a question, you can't just try it with different numbers. You have to algebraically show that it is true all of the time if that's what you need to do. So let's have a quick look at an example. Okay guys, so we've got an example right here. It says, prove that the product of two odd numbers is always odd. So that means any odd number times an odd number is odd. So, I mean, this makes sense. You can think about it. Think about any two odd numbers. Notice how when you times them together, they make another odd number. They never make an even number. But how do you prove it? How do you show that it's true for every single two odd numbers, right? Because you can come up with lots of examples, but there's an infinite number of numbers. You can't prove it for every single one individually. It would be ridiculous. Are you seriously going to try and times out all infinitely many numbers in every combination you can of every odd number? No, of course you're not. So what you're going to do is you're going to generalize this. So one thing that you can do, and we'll do lots of videos in this in the future, one thing that's really powerful that you can do is you have an algebraic way to express odd and even numbers because of this mathematical fact. This is where the mathematical previously established ones come in. So think about any odd number. Think about any even number. When you double any number, odd or even, if you times it by 2, can we agree that it's an even number? It's on the 2 times table, right? 2 times any whole number is even. 2 times 1, 2 times 49, 2 times 30, 2 times 31, 2 times, think of any number you want, double it, it's even. So what we can say is an even number can be written as and we'll just say k, use lots of different letters. You can use p, q, whatever you want. We'll say k. And we have to say k is a whole number. So the way that we write the k as a whole number in mathematical notation is we say k is an element, so that's an epsilon. K is an element of, and what you can do is you can write a sort of thick N like this. This means K is an element of the natural numbers. So that weird N, that's capital N, it means the natural numbers, the set of natural numbers. Natural numbers are counting numbers. 1, 2, 3, 4, 5, 6, 7, 8, etc. You could also, if you wanted to, say K is an element and do a thick Z and a plus. This means the positive integers. The positive integers are just, because integers are whole numbers, but they could also be negative. If you put a plus sign up there, you get just the positive ones. It means the same thing, really. It's either the positive integers or the natural numbers. Either of them are totally valid. Or you can write down in English, k is a whole number and it's positive. You can do that too. It's your choice. I would go with natural numbers. It's just a bit easier. So we'll say that k is an element of the natural numbers. That's an even number because it doesn't matter what k is. K could be any number. If you double it, it's going to be even. So an even number can be written as 2k. An odd number is very similar because you can use the fact that if you double any number to get an even, well, if you just add 1 to it, it must be odd. Because if you have an even number and you add 1, it's odd, right? Think about any even number, add 1, it must be odd. So we can write an odd number as 2k, which is it must be even, just plus 1, right? And we can then say again, k is an element of the natural numbers. K is a positive whole number. Amazing. So we don't need the evens for this question. We just need the odds. So the product of any two odd numbers, let's call them, we'll call one of the odd numbers 2k plus 1, and where k is any integer that we want. And we'll call another one of them, let's say, I'll just use a different letter, 2p plus 1. This is just a different odd number. It's 2 times a different, or maybe the same, whole number. And we can also say that p is also a natural number. And p is also 2p plus 1. So what we're saying right now with the 2k plus 1 times 2p plus 1 is this is two odd numbers multiplying together. It has to be. They could be the same. They could also be different because k and p can be different numbers. And all we do is we expand this out. This is two odd numbers timesing together. So we expand the brackets out. You get 4kp outside, so you get plus 2k. Inside, you get 2p. And last, you get 1 times 1, which is 1. And now what you do is to show that something is either odd or even. If you want to show it's even, you just factor a 2 out. Because again, by definition, an even number is a multiple of 2. If you want to show it's odd, you factor a 2 out, but you leave a plus 1 on the outside of the brackets. Because that's an even number again, plus 1. So what we can do is we can write this as two lots of 2kp plus 1k plus 1p. And then outside of the brackets, the plus 1 is still there. Do we agree that these are the same? I hope so. And what this is saying is, because k and p are whole numbers, 2 times any whole number is still a whole number. And then times that by a different whole number, it's still a whole number. Plus another whole number to that, it's still a whole number. And then plus another whole number to that, it's still a whole number. So what we can say is that 2kp plus k plus p is also a natural number. So let's just call that q, right? It doesn't matter what it is. It's just a whole number. And q, once again, is a natural number. It's a whole number. It's a counting number. We don't know what it is, though. Which means that the product of any two odd numbers is in the form 2q plus 1, which, by the exact same logic as last time, this must be an odd number. So then we'd finish it off by saying, therefore, and basically just repeating what the question says. So, therefore, the product of any two odd numbers is odd. Must be. We've just proven it. That is one way to do these proofs. There are lots of ways to do proofs. You will see multiple ways to do them in your A-level maths career. And if you do A-level further maths, you'll see yet another way to do it. But this is the gist of it. It's about using mathematical reasoning to prove things generally for all cases. So in the next few videos, we'll do a few other examples to get really used to this. Thank you guys so much for watching. Highly appreciate it. And I'll see you in the next video. Cheers.